In this video, we are going to look at travel graphs. Now, travel graphs show the distance traveled from a starting point, and they also show the time taken. They're sometimes called distance time graphs, and you can see one just here. You can see that we've got distance on the y-axis, and we've got time along the x-axis. And what this is showing us, it says the following graph gives the distance of a cyclist from his home. So when we're talking about distance, we're talking about the distance from his home. So the cyclist starts at his home at 8 a.m, you can see that, and then he travels away from his home, then he stops for a little bit, and then he keeps traveling away from his home, then he stops again, and then he travels back home. So what's important to see here is that when we have a positive slope, what that means is that from left to right, the line segment is going up. So any sections where the line segment is going up from left to right, we say that that has a positive slope. That means that the person is moving away from their starting point. I'm going to write home here because in this example, it is the distance from his home. It's not always. Sometimes it's, the distance from the shopping centre, or sometimes it's the distance from their school. You'll see plenty of different examples. But it means that they're moving away from their wherever they started. And we can see that because the distance is increasing. At this point, the cyclist is at home, but when he gets here, he's 20 kilometers from home. Then when he's here, he's now 60 kilometers from home. So the distance is increasing, which is why he's moving away from home. Now, sections with a negative slope, meaning left, when we're going left to right, the line segment is going down. That means it has a negative slope. As we go from left to right, the line segment is going down. Any times when that's happening, that means that we are moving back towards home. Now we can see that with the cyclist. At this point, he's 60 kilometers from home, and here he's now back at home. This line here represents 0 kilometers from home. So here he's 0 kilometers from home, and here he's 0 kilometers from home. So it means he starts at home, he goes on his cycle, and then he finishes back at home here. So anything with a negative line segment, or a negative slope, I should say, means that they're moving back towards home. Okay, horizontal line segments. I did talk about this just at the beginning, but what we can see here on these horizontal sections, his distance from home is not increasing or decreasing. So he starts here at home, he travels for 20 kilometers, and then during this orange section, he's not traveling further away from home, and he's not coming back towards home. He's just staying 20 kilometers from home. So what that means, since he's not traveling either further away and he's not traveling back towards home, this means that he is stopped. He is not moving at this point because his distance from home is not increasing or decreasing. It's staying at 20 kilometers. And the same is happening up here in this line segment at 60 kilometers. He's not getting further away from home. He's not coming back towards home. He's staying 60 kilometers away, which means he's also stopped. Now, sometimes in maths, instead of saying that he's stopped, another word that we usually use is stationary. Now, not stationary like pens and pencils, stationary with an A instead of an E, which means not moving. Okay, one other thing I want you to realize is we're going to actually talk about the slope now. And we're going to talk about when it's steep and when it's flat and what that means. So let's look at this first line segment here. Okay. Now in this section of the graph, the cyclist travelled 20 kilometres and it took him from 8 a.m. till 10 a.m. It took him 2 hours. So 20 kilometres in 2 hours. Whereas up here, he travelled now from 20. He went from 20 kilometres to 60. So he travelled 40 kilometres in, how long did it take him this time? In 3 hours. So this was 20 kilometres in 2 hours, and that one's 40 kilometres in 3 hours. Now, what we need to see is that when the line segment is steeper, that means the cyclist is travelling more distance in a shorter amount of time. So where the line segment is steeper, it means that the cyclist is travelling further in a shorter amount of time. So let's write that down here. Steeper slope means they are travelling faster, in other words. Because they're travelling a more distance in a small amount of time, means they're actually travelling faster. And we can see that back here. This was 20 kilometres in 2 hours, so that's 10 kilometres per hour. And this was 40 kilometres in 3 hours, that's actually 13.3 kilometres each hour. And it's a little bit hard to see with this one because it's not a big difference. But this second line segment here is actually steeper than this first one. We can see it a little bit better maybe with this line segment here because this last one is obviously the steepest line segment. Okay, this means that the cyclist travelled 60, he went from 60 kilometres to 0 kilometres, so he travelled 60 kilometres in just 2 hours. So 60 kilometres in 2 hours, which means he's going about 30 kilometres each hour. And you can see that's much quicker than these speeds here, and it's a much steeper line segment. Okay, so if you're a bit confused about the speeds, don't worry, we're going to go into much more detail about that later. What I need you to recognise is that when the line segment is steeper, that means they're travelling at a faster speed. And when it's flatter, that means they're travelling at a slower speed. So if the question asks, when is the cyclist travelling the fastest, you're just looking for the section with the steepest slope. If they ask when is the travelling the slowest, you're looking for the section with the flattest slope. Let's have a look at some examples of this. We're going to answer some questions on this graph just below. Let's have a look. It says, when did the cyclist leave home? Well, we can see that he started at home at 8 o'clock and that's when he started to travel. So the answer is 8 a.m. When did the cyclist return home? So he went for his cycle and he came back home at 5 p.m. So he got home at 5 p.m. How far away from home was he at 10 a.m.? Okay, well, let's have a look. 10 a.m., what was his distance? He was 20 kilometres from home at 10 a.m. D, how far away from home was he at 11 a.m.? Well, let's have a look. 11 a.m., he was still 20 kilometres from home. Same distance because between 10 and 11 he was stationary. How far away from home was he at 2 p.m.? Well, at 2 p.m., he was 60 kilometers from home. And how far away from home was he at 3 p.m.? At 3 p.m., he was still 60 kilometers. At what times did he take a rest? So remember, he took a rest when he was stopped or stationary. That's when we have horizontal line sections. So let's have a look here. We've got a horizontal line segment here and one here. So that means he was stopped between 10 and 11 and 2 and 3. So at what times did he take a rest? 10 a.m. to 11 a.m. and 2 p.m. to 3 p.m. Okay. How far away from home was he at noon? Remember, noon means midday. So this one's a little bit harder, okay, because it's not going to be as easy to read from the graph. So at 12 o'clock, and then we've got to follow it across. I'm going to say this is 35, so I'm going to say maybe 32.5 kilometers. I'm going to say halfway between. 32.5 kilometers. How far from home was he at 5 p.m.? Well, let's have a look. At 5 p.m. he was at home. He got back home at 5 p.m. So he will be 0 kilometers from home at 5 p.m. Okay, find his speed in these time sections. Now, we talked about this before, but I'll do it in a little bit more detail now. 8 a.m. to 10 a.m. Okay, so we learnt in the previous worksheet that speed equals distance over time. So what I need to work out is what distance did he travel between 8 and 10, and how long did it take him? Well, clearly from this, the time is 2 hours. From 8 a.m. to 10 a.m., that's 2 hours. Now I just need to work out from the graph, how far did he travel? So from 8 to 10, what I need to work out, this is the distance that he travelled. He went from 0 kilometres to 20 kilometres. So the distance will be 20, and the time that it took is 2 hours. So it'll be 20 over 2, which will be 10 kilometres per hour. So that's for part 1. Part 2. From 11 a.m. to 2 p.m. So let's have a look. Just clear all of this so we can see a bit clearer. From 11 a.m. to 2 p.m. All right. What I need to work out is what distance did he travel. Now, a common mistake is for people to say he travelled 60 kilometres. What I'm actually trying to find out is what distance did he travel from 11 to 2. So that distance is only, the distance I'm looking for is only this distance here. So he was 20 kilometers away. He ended up 60 kilometers away. So the distance is actually 40. And the time, well, 11 to 2, that's 3 hours. So again, using my formula, speed equals distance over time. He travelled 40 kilometers in 3 hours, which is 13.3 kilometers per hour. And part 3, it says from 3 p.m. to 5 p.m. So what distance did he travel from 3 to 5, well, that was the whole 60 kilometers, because at 3 p.m. he was 60 kilometers from home, and at 5 p.m. he was back at home, so that's 60. And how long did it take? 2 hours. So speed equals distance over time, 60 over 2, which is 30 kilometers per hour. And the last question, when was the cyclist travelling most quickly? Well, two ways we can work that out. Firstly, looking at the graph and saying which section has the steepest slope. And I can see from the graph that this section has the steepest slope. But also, I just calculated all of the speeds. So he's travelling the fastest when the speed is quickest or largest, which would be in part 3 when he's travelling 30 kilometres an hour. So when was the cyclist travelling the quickest? It would be between 3 to 5 p.m.